welcome to everybody joining us on our webinar series, where today we're going to be talking about all things wireless, not just Wi-Fi. So we're going to be actually covering some other technologies such as private 4G, 5G, BLE, ultra-wideband, and I think even Zigbee, and also some of the things to consider when you're going to be designing for these other technologies as well as Wi-Fi. So without further ado, I'll pass it over to Troy to give us a quick introduction.
So we have some of our usual suspects. You just heard from Matt Starling, who'll be guiding us through today's presentation. We also have Stu here, who started us off with the introductions here, in charge of community and customer engagement, attending a lot of conferences and events, always super eager to meet everyone in person and engage with others. We have Dale Tyler representing the sales side of the house, but the technical sales side. Myself, Troy Martin. And lastly, we have our special guest, the star of the show today, Hans, who will be guiding us through a lot of best practices when it comes to Wi-Fi and other wireless related designs. So let's get on with this.
Yeah, Hans, it was very great to have you here on the webinar today, but also we actually got to present together for the first time yesterday.
Yeah, it was great. It was really great. Big fun. Nice to be able to present to Waiko. So it was fun. Yeah.
Yeah, so never presented together before, and then twice in 2 days. Lucky us. So glad to have you join us, Hans. But yeah, what are we actually going to be covering in today's webinar specifically, Troy?
Yeah, so the plan for today, as we talked about, we'll start off with Wi-Fi, right? Looking at key concepts, fundamentals that enable you and set you up to be successful as part of your Wi-Fi designs. But we're also going to branch out into other wireless technologies, right? We're all, a group of geeks here. Wi-Fi is very exciting, but we keep seeing more and more wireless enhancements added to a lot of vendor products, right? So they're including some IoT radios. There's other technologies that tie into location and tracking. So we'll be talking about some of those best practices and how you can start looking at those other wireless technologies as part of your designs. And then we'll end with some time for some Q&A and some announcements about some upcoming exciting webinars that you may be interested in.
Now, why wireless network design matters? Because it's important that you design, you make your design, and you discuss what you want to achieve. Because if your Wi-Fi or your wireless network is not delivering, you might lose some revenue, or your productivity if you can't find some gear, you have some assets in your company. That's what you want to avoid at all times. So making sure you have the right requirements there, and that you have a good design, that's key in this. In any wireless technology. So it's your Wi-Fi network has to be reliable, maybe build in some redundancy if you can, and then it all starts with your design. Poor Wi-Fi, basically the result of poor Wi-Fi is when there's no design done. Just cookie cutter. It worked last time, so it will work this time. So we need a case by case design for this, depending on technology. Now, there's a saying, no good configuration can fix a bad design. So you can be the master of your vendor, but if you fail to do a good design, well, you're probably going to have you may have a bad result. So first do the design and configuration comes after. So that's what we need to remember. Now we have some core principles we need to go through, which we need to remember. So first, we need to get our requirements right. Matt?
Yeah, I couldn't agree with what you said anymore, Hans. But it what we've outlined here doesn't necessarily just translate for your Wi-Fi network designs that you're going to be doing, but also can translate for any kind of like wireless deployment or network deployment that you're planning to do. So if you're designing for Wi-Fi, cellular, ultra wideband, BLE, you can take these principles and best practices and apply that to those networks and those designs too. And the biggest one is making sure you understand the requirements that you're going to be doing this project for. So speaking with the stakeholder, really understanding like what it is they're looking to achieve. If it's a Wi-Fi deployment, is it going to be for voice and video calls? Is it going to be for typical office application? Is it for providing coverage in a warehouse? If you're going to be designing for using, I don't know, something like ultra wideband for some asset management, how accurate does it need to be? What are the specific devices that are going to be in use? Is it on phones? Is it on tags, etc., etc.? Then understanding your environment is so key to go to site, know the materials that you have there, know where you can place access points or beacons or anchors or whatever it is you're going to be placing around the environment. Go there, measure, find out what's going on, see if there's also any kind of interference, what that might be causing you configuration decisions to make with what channels to use and transmit powers. Also, use the right tools to help you cover the areas that you'd like to have the network in, whilst not also covering the places that you don't want them in, because you don't want to waste and cover a lot of areas that are not necessarily in scope versus the places that are in scope and focus there. And then finally, making sure that you optimize your design once it's been deployed. You can tweak so many things when it comes to transmit power, channels, the channel widths, and all these other things. So understanding these, you can take these core principles and best practices and apply it across multiple different wireless technologies. But maybe Troy, you can help us explain a little bit about how we get those requirements and then translate them.
Yeah, to your point there, I think it's funny that when you mentioned covering what areas that you want to cover and try not to cover those other areas, that's certainly one way of looking at things, right? If you wanted to overrun your budget, if you wanted to fund the sales boat for the or the boat for the salesperson, buying twice as many access points as you needed to, then certainly over design and shoot beyond what your targets were. But in order to be effective as part of your design, one of the things I like to recommend people is just think about the question. It's sort of a philosophical question is how do you design or how do you evaluate rather the perfect design? How do you quantify one design being better than the other? Right? So one of the things that I like to think about is the best designs are the ones that use the fewest or the least number of access points, but still meet all of the design requirements. Right? So the fewest access points, but meet all the design requirements. And it sounds simple, but it actually is quite complex, right? And the key to that is understanding what all the design requirements are. And that's where you should invest a significant amount of your time upfront, working with your stakeholders or end customers and clients, asking questions almost to the point where you become annoying, that they just want to move on with the project and keep asking you, just put in the access points, just get it working, right? Before you can do that, you need to understand what their goals are, what are their outcomes that they expect, what level of service do they expect, and to guide you through that process. I always recommend starting off with the business requirements, right? The business is the one funding this project. They're the ones that are going to benefit from the deliverables of using this wireless network, right? What are those business purposes, right? And there it could be, we want to work 15% more effective, right? We want to accomplish tasks earlier. Or maybe in a warehouse, you need to access a back-end inventory management system, right? And due to legacy reasons, that inventory management system cannot handle latency or delays in the heartbeat more than 100 milliseconds, right? So now, as part of the business requirement to enable sending data, updating inventory in that management system, you need to design a system that will not exceed 100 milliseconds between heartbeats, right? So you work through all of your business purposes, business requirements, right? Then you transition into the technical requirements where you're looking at things like which manufacturer, which AP model might provide our requirements. I want to make sure that you're defining which areas are in scope and which ones are out of scope, right? As Matt pointed out earlier, you don't want to add APs in a location that's unnecessary. You want to be mindful of things like your regulatory domains. You might have legal requirements, right, where you have responsibilities to keep data private, or you're not able to collect user or customer information, right? So how do you work around those regulatory and legal requirements as you put together your solution? And then lastly, I often hear from customers that when you ask them, how well do you want the Wi-Fi to perform? They just say, I want it to be good, or I want the Wi-Fi to be great, right? Well, it's really tough to design to a level of greatness, or even harder, how do you validate that your network meets greatness, right? If you can translate that into a threshold of RSSI coverage, SNR targets, co-channel interference thresholds, and then you can design to those specific targets. And more importantly, you can evaluate against those to confirm that your network actually meets those targets and sign off on that installation or that deployment, right? So working through this three-step process really sets you up to be successful and implement a good design so that you don't have to worry about trying to fix things or partially fixing things through a configuration.
Yeah, and I think the thing that we're probably most familiar with looking at and seeing when you're talking about some sort of wireless project is the coverage, the signal strength you're going to see from your access points. And I think in Wi-Fi we're all quite familiar with designing to a certain threshold. So I think Troy, you might have mentioned it there. That typically sometimes in Wi-Fi we're going to be for primary coverage looking at like neg 67. Maybe you go a little bit stronger than neg 65, and then if you've got secondary coverage as well because you're thinking about roaming and redundancy. But when we're talking about what designing for not just Wi-Fi but wireless, it's understanding like what kind of thresholds do we want to be achieving at a minimum for these other technologies like 4G, 5G, and what do those kind of acronyms mean instead? So instead of designing for like neg 67 primary RSSI, maybe we're going to be looking at a different value or threshold to meet for RSRP values. And the reason why we want to achieve these minimum thresholds is typically so we can achieve a minimum signal to noise ratio, achieve good data rates, good transfer of our modulation schemes to be able to send good connectivity over that wireless connectivity. But coverage is one of the things that we have to think about when it comes to our designs. But there's also something else, Hans, that people maybe sometimes overlook or maybe not quite grasp how important it can be. And I think that's probably around capacity planning, would you say?
Yeah, because coverage is easy, but capacity planning is something that you have to really define radio by radio and see, okay, how much clients am I expecting on 5 GHz, on 6 GHz, and what demand do I have? Because this is application by application. If you're going to run just barcode scanning or you're going to use video streams or voice calls, you're going to have different demands. So you have to estimate, you have to have a take rate, how many clients you estimate that's going to be active at a single a moment in time. And then you can provide that numbers and test that in your actual environment, in your actual design to see, can my network handle that load of my clients? This is one of the key principles, which this is something you cannot measure in reality. This is something you have to estimate and you have to plan for before you can actually do the installation. Now, you have to plan, but just planning from an free space path loss perspective is not realistic because we want to plan for our clients. We want to plan for our barcode scanners, for our handheld phones. Typically, they are not the strongest. They may have lower sensitivity. They may have smaller antennas, radios. So we need to make sure that we have the LCMI, the least capable, most important. So our business critical device that has to have a good signal. Either it's Wi-Fi or other technology that we need to design for. So defining the LCMI is critical before you can do a real design. Now, next to that is also your environment, your building. What kind of walls is it glass? Is it drywall? Is it brick? You want to define the right wall type. Maybe doing a wall attenuation measurement. You measure in front of the wall, you measure on the other side of the wall, and then you have a value. Okay, this is the actual value for a certain wall, and you can build your own walls. So there are some defaults into Ekahau, but you can build your own walls. How does that all work into AI Pro Online? So we can have a two-dimensional view we have been using that for many years, but to get a real insight in if you start using racks, if you start using equipment, furniture into your offices, how does it look like in reality? A human being is an attenuator, so how do they look like if they're in front of your AP? So to show all this, this
Just while Hans is getting that set up, Matt, I have a question for you. Which one's more important, coverage or capacity? Can you make that distinction?
Oh, that's a good. It's a good question. The Wi-Fi doesn't work well with if you don't have a good coverage, you're not going to have a good performing Wi-Fi network. But then on the flip side, if you don't have a well-planned network for capacity and you've got too many people trying to connect and associate, they're not going to work well either. So yeah, that's a tough one to decide on. But I think at a minimum you have to have coverage. If you don't have coverage, you're not going to have connectivity. So even if you was planning for capacity, if the coverage isn't there, those people aren't going to be able to connect. So if I had to make a decision, I'm going to lean. I know maybe controversial, but I'm going to lean more towards coverage.
Yeah, but like in this case, we have here a stadium, an arena where we can provide Wi-Fi. So we build a stadium using the elevated surfaces. Um, now we can schedule. Now we can design a Wi-Fi network for these kind of environments. So you can put APs. How do you start with this? The first thing is where can you put APs? Because defining where you want to have the EPs, is it in the seats, and you want to have them under seat? When you put the EPs on the ceiling, is there space on the ceiling? Can you mount them even there? How should you place them? So if we dive into this, um, if I'm going to place an AP in here, so let's take this AP. I'm going to set the height. Um, for this AP 5050 for extreme. And if I place this one on the seatings here, now this is the coverage that I have. So with just one AP, I can I can design for the whole pitch here. So I have coverages. In this case, coverage is easy. But what happens if I take this AP and once if I move it in between, there's some people here. So in this area, there's some people standing, and now the coverage for this EP, you see? Now it's in between the people. So now for these 3 rows of people, we do have coverage. So a human body is an attenuator that we need to take into consideration because if you don't place the people in there, you're gonna have coverage everywhere. But once you start putting people in there, they're gonna block your signal. Now, under seat is one of the solutions if you want to place Wi-Fi into an arena like this. Now, another possibility is when you put them on the ceilings. So if we take another AP from this range, so we're going to take the 5050D, but now a narrow one with a narrow antenna. So we can place this one. I'm going to place it on the ceiling in this case. And I'm going to put them 12 meters high in the ceiling. So now this one, it's on the ceiling now. Yeah? So, but you see, it's covering a long end. I can tilt it. So maybe if I tilt it inside the arena, um, or I can move it away from it. So now I'm going to cover more into where my people are because typically a stadium is a steep yeah, is going up. So in that case, I have my full coverage. Um, Problems lie in where you're going to do cabling, and you need to do cabling. Do you have enough IDFs in there? And do I have the possibility for my cabling there? So and this way, but in this case, it's a stadium for sports events. What if you want to start doing concerts in this kind of stadium? Can you design for that? So you have to decide on, again, going to your design principles, getting your requirements right. Where should I place my EPs to provide enough coverage? So this way, using on the seatings, under seat or in the ceiling, putting Wi-Fi over there, we can have a good coverage everywhere and provide the necessary capacity to have everyone in there and provide them a good Wi-Fi signal.
So Hans, just a quick question around the arena that you've got built out here. So a few people are asking around the 3D view that we have, and now like this advanced 3D modeling capabilities with the raised platforms, and you've even done some like human attenuation here. And you've spoken about a few different design potential options here with like undersea, overhead, and then planning for maybe not just people in the bowl, but also for the concerts. I appreciate that we're on like a limited time here for the webinar today. But I believe that this is also covered in our latest new advanced class that you teach for us as well. Is that right, Hans?
Yeah, yeah. In design class, we're gonna go in depth on this one. We're gonna design this whole stadium during some exercises, and we're gonna dive in each part step by step. So yeah, we're gonna do this in the design courses, and we're gonna have lots of fun with it.
Perfect. Yeah. So the new advanced class is going to dive right into all of these nice features so you can design advanced venues like this. So manufacturing, arenas, you name it, you can design for it in our new advanced class. But we're talking about wireless today. So actually, I think Troy, it's about time you start talking about some pie.
Absolutely. Pie, one of my favorite desserts.
Yep.
Right. And we're going to go beyond just designing for Wi-Fi. I find so many people in the Wi-Fi community, when we start talking about wireless and Wi-Fi, they use those names interchangeably, seeing only one slice of the pie, right? So about a week ago, I just put out a post on LinkedIn, kind of promoting this webinar, talking about wireless. As I mentioned, I'm a big fan of pie, and I'm just curious, maybe even in the chat, just drop in your favorite pie that you guys like eating. Mine happens to be Saskatoon berry pie served warm with a dollop of vanilla ice cream, right? But if we look at a wireless pie, right, if we just wanted to expand our taste buds a little bit, we could start looking at things like BLE, ultra-wideband, private 4G and 5G, or even some of those other IoT technologies that we're seeing built into some access points coming out on the markets that include Zigbee radios, right? Setting us up for Matter, another IoT technology, a lot of these built on the IEEE, the 802.15.4 standard itself, right? So we're going to follow up now on a breakdown of different wireless technologies that we can include and look at use cases that they offer to augment the ability for you to meet your customers' business requirements, right? Because as great as Wi-Fi is, sometimes it's not the only or the best solution to the problem. So let's take a look at that now.
Yeah, so there's a few different verticals and enterprises that you would potentially use these different technologies for. We just wanted to give you a couple of examples here. So for healthcare, you would potentially see a lot of BLE or ultra wideband sensors or access points that have these radios inside of them so that it can be used for things like asset tracking, wayfinding. So perhaps you need to go and locate a nurse, a potential doctor, or a particular medical device, or hospitals are so big sometimes you want to figure out how to get from ward A to go to X-ray Z sort of thing. So having those types of technologies is going to be very helpful to guide and track users and devices in those environments. In a corporate office, I think more and more we see people wanting to understand how occupied rooms are, how occupied meetings rooms are, if you want to book some time to go and have a call somewhere. So you can use technology like BLE for monitoring that. And in the manufacturing space, I think this is a really good vertical for potentially leveraging some technologies like private 5G, and also even things like ultra wideband as well, because being able to provide like connectivity and coverage for some of the devices in here that could potentially be using scanners or phones or devices that have got these SIM cards that can connect to the private cellular. But also we have seen ultra wideband be used in manufacturing and in warehouses, and I've experienced this myself going to a quite a large warehouse where we actually had to carry on our person an ultra wideband sensor, and each forklift truck would have another ultra wideband sensor on it. And as you would come into close vicinity with the forklift truck, it would actually automatically slow down the forklift truck to stop there from being any kind of accidents, which is a really cool way of using that technology. So you're going to see more and more these different technologies being used in these different environments and verticals. And actually, that's why with our Ekahau AI Pro Online, we now support using and leveraging these new technologies. So yeah, if you just go to the next slide, thank you, Troy. So very soon, I think from early next week, you're going to be able to start planning your wireless networks in AI Pro Online for these other technologies, doing it in the way that you would probably be quite familiar with the traditional predictive modeling. But we actually have a really nice, cool way that you can design for these technologies, but by using your Sidekick 2 data that was collected of the Wi-Fi environment. So what we can do is if you've done a survey of your environment with the Psychic 2, even going back however many years, 3, 4 years ago, data collected with the Psychic 2, if you push that to Ekahau AI Pro Online, we will use our machine learning, our AI, and machine learning algorithms to understand how RF propagates in your environment. So you can then plan to move your Wi-Fi access points around or do a redesign. But also, if you want to plan to design for other technologies such as cellular, ultra-wideband, or Bluetooth, you can place those devices and see those heat maps update based on the measured data that you collected with your Psychic 2, which is pretty cool. And Troy's going to give you a nice live demo of that coming up shortly later on today.
And actually, we're gonna jump into that right now, give you guys a demo of what that looks like. So I can flip to an existing project. And as Matt pointed out, this is one of the values that the Sidekick 2 brings you. That if you've done a survey, and it could be a survey that you performed 5 years ago, right? As long as you followed best practices for performing that survey, things like walking on both sides of the wall, making sure you're going into all the rooms. If you have that data, with the measurements that were collected, we can now, thanks to our R&D team here at Ookla and Ekahau, they've confirmed that we can derive and estimate the signal attenuation and propagation effects across multiple frequencies, right? Because the wireless IoT technologies that we're going to be talking about today, private 4G and 5G, they use frequencies outside what we're used to for Wi-Fi, right? But we can still leverage that data we collected, and we can estimate the impacts of attenuation objects like walls and machinery, warehouse racks. So that gives you an idea as you build these models where you can best place these access points or your RAN radios to get good coverage. All right, so here we have an existing deployment, right? And let's just jump to the basement floor here. Pretend that we're putting APs in the basement, right? And we see a heat map that we're very used to looking at, showing us Wi-Fi signals, Wi-Fi performance, right? But I can go ahead and I can select from my list now in my technology dropdown. I get a list of multiple wireless technologies and devices that I can add, right? So this could include things like obviously Wi-Fi, but Bluetooth, your cellular, your private 4G, 5G, Zigbee, and ultra-wideband, right? And we'll be giving you demos of all these wireless technologies later on in the webinar. But what I want to focus on here is that if I pick just as an example, cellular 4G, right? Once I've selected that, I then have the ability to choose multiple frequency bands, right? Now, unfortunately, at this time, we don't have an exhaustive list of all the private 4G, 5G frequency bands that could be there. This is an evolving list. As we add more products to our AI Pro Online, list will expand to include more frequency ranges. But for this demo, I just want to focus on the CBRS band, right? So if you've heard of band 48, right? That's the CBRS band that's commonly used in the US. And then from this list, we have a list of different manufacturers, right? And again, not exhaustive, but we're aggressively looking at populating this list with additional manufacturers. So if you do see that some AP models or radio products that you want to use in your deployments, if they're not included on this list, reach out and we will get them added as quickly as we possibly can. So if I focused on a Soluna, grabbed one of their products, I can then drop it in, right? And if I zoom in on this, right, we can see the coverage of this AP. And as I move in and out of rooms where I measure the attenuation, we can see the impact of the measured data across my different environment, right? So then I could use this to try to figure out what's the ideal placement for positioning this radio to give myself the best coverage that I need, right? Obviously, you can tune the transmit power. set it to what's reasonable for your deployments. If you wanted to create smaller cells, add in additional radios for overlapping coverage and redundancy in case the uplink Ethernet connection got cut or severed, you could do that as part of your design. But you have lots of different options of what you want to achieve as you go through this, right? We could also look at another scenario, right? So not only can we grab an attenuation model for an existing deployment, we could look at a net new design if we wanted to consider something like that. So in this scenario here, we have a warehouse design, right? And this warehouse, again, leveraging AI Pro Online, we can model this in 3D. So we have the warehouse racks at various heights, representing different styles of shelving and material that they want to hold on those warehouses. Different blocks representing perhaps some machinery items, right? Or giant water tanks, if you think of mechanical areas in various buildings, right? And of course, the doors and office space, that you typically find in various environments, right? By clicking on the device tool here, we have the typical Wi-Fi devices that you're used to seeing, but then we can break down and look at many different other components, right? One thing to keep in mind is that some devices, or when we pick these devices, sometimes we're looking at devices that only perform one function, right? So in the 4G section, that'd be devices that are generally only 4G capable. Whereas if you were to add an access point that had an integrated BLE radio and Zigbee or ultra-wideband in it, maybe select that from the Wi-Fi drop-down list to add that device, but then we can apply the right visualizations to look at that. So if I look again, actually, let's try 5G, right? Let's think towards the future. Try a new radio, right? We can grab Airspan as a model, and I could drop these in, right? So a few different models with some different antenna options that we could use and can select. And if I was to place one of these into this design, right? I have my access point mounted up into the ceiling, and by default, for this AP, it's being placed up at the height of my warehouse, 4.9 meters, but it's positioned on the wall, right? So if I come in here, I can play with this and I could ceiling mount this access point to give it a little bit of a focus down towards the ground. I can also adjust the tilt, right? Give it a different tilt and orientation, move this access point around to try to deliver the coverage that I'd like to see at this site. And so here we're almost looking at like a Pico level design, right? Where we're covering very small areas, very focused environments to get us the specific coverage that we're looking at, right? In my visualizations here, you can see that because I've just deployed a 5G radio, my visualization changes to look at heat maps specific to the private 4G, 5G technologies, right? So I can look at things like my RSRP, and this is sort of where I find it's not exactly the same thing, but it's quite similar to what we're used to looking at RSSI. I find that in the cellular space and the Wi-Fi space, we often change names of things. Sometimes it seems just to come up with a different name, right? If you look at OFDMA as an example, in Wi-Fi, we call them resource units or RUs, the individual subcarriers, right? But in cellular, when they talk about OFDMA, we call them resource blocks, right? Same concept, but we have to give them different names, which I find a little bit interesting. So very similar concepts to primary, secondary, RSSI. We have the RSRPs. You have your signal to noise ratios or signal to noise interference ratios that you can use and visualize to measure your performance, right? So very similar what you're used to when performing Wi-Fi design. Now within the same product, all integrated within AI Pro Online, you can look at not only just Wi-Fi, but also your private 4G and 5G designs, right? All in one product, and then easily switch between those heat maps and visualizations to put together your complete projects, which then can then deliver on all of the design requirements to meet your business and technology objectives for the projects that you're working on. All right, just some follow-up things to think about, right? As part of private 4G and 5G, right? This is where it depends a lot on the country that you're working on deploying, right? And so there's a lot of regulatory complexities. Sometimes you can leverage some dedicated spectrum that's been allocated for people to use like the CBRS band. Other countries, you're working with your carriers to try license some spectrum that they already own the rights to, right? So if you imagine, a large country like Canada, very spread out, we have a lot of space where there are no people, right? But the carriers have purchased the licensed rights to particular spectrum, right? So not just anybody can use that, but there are areas of the country where we have, lots of mines, right? Could be some oil and gas mines, diamond mines, potash mines. But these sites where there's no people around, so those providers are not getting any revenue from subscribers. And so it may be a value for them to kind of rent or lease out that spectrum to that mine so they can deploy a private 4G, 5G deployment in that environment. The carrier gets a little bit of revenue from the spectrum that they own, but then you can get some benefits by providing that 4G, 5G solution for the devices that need to connect over a massive area that could be 10 or 20 square kilometers to get devices connecting, passing traffic, keep tabs on, autonomous haulage vehicles, driving routes up and down the mine roads. Okay. So when we talk about those use cases, some of them could obviously be the autonomous haulage vehicles, or sometimes we call them, automated guided vehicles, right? But these are vehicles that have no person driving them, right? Which saves and provides a lot of efficiency, right? No one needs to take bathroom breaks. Sometimes just to get to the trucks, by the time you get from the security gate into the seat of that truck, it may take a person an hour just to get there, and then an hour to leave site at the end of the day. So you've lost 2 hours of person time during every shift, right? Where if they were self-driving, you wouldn't have those inefficiencies, right? You could brake and accelerate at optimal rates, preventing wear and tear on the machine components, saving motors, wear and tear on the tires, tons of efficiency gains from making that happen, right? So these are pretty harsh environments that people are better served in other areas performing other functions in those mine environments. You can also have IoT visibility, right? Imagine a scenario in agriculture. You have a massive field where you have a large herd of cattle spread out across that field. They're, diving into that grass-fed, free-range, living the happiest cow life that they can. But they need to get called in for regular milking, right? Now you can keep track on those cows, or it could be sheep out in the field. You could have sheep wandering around a solar field, right? They're trimming the grass, keeping it from getting too tall, too long. But you want to make sure that where your sheep are on the field, that they're all accounted for, those kind of things, keeping track on your livestock assets, or it could be robots tearing around a warehouse environment, right? So lots of different applications for using 4G at large distances, or in specific scenarios where you need to guarantee low latency for delivery of safety instructions, either to open and close equipment, turning off motors to prevent, loss of limbs of people working on conveyor belts or other pieces of very large and powerful equipment. Okay, and then we just walked through that private 4G, 5G demo for you guys there, right? Now we do have default values built into the software, right, to give you a guide. But often I kind of laugh when we have big debates about, what should the default values be, and then is that the right default value? Defaults are a starting point, right, to get you going out of the gate. Obviously, you could use them if that's what you wanted to use. But if you need to refine your design, you are the owner, you're the designer of that system. So pick the appropriate values that you need, again, to deliver on those design requirements. But the system settings are a good starting point to those default values to get you going, but you can tweak those as you need. And that goes across all the wireless technologies. All right, so let's jump into the next wireless technology, and I'll hand the floor back over to Hans to guide us through Zigbee.
Yeah. So Zigbee, where do we gonna use Zigbee? Typically for home automation or building automation. One of the key features there is it's gonna build a mesh. So all the adapters are gonna build a mesh with each other, so you can hop between different routers, Zigbee routers, to build the full channel. So typically we're gonna work in 2.4. So Zigbee is operating in 2.4, but can for different locations like US or Europe work also in sub 1 gig area. So we have in 2.4 16 channels available. So it can spread up amongst the 2.4 gigahertz. So typically we're going to need some kind of a gateway a coordinator, which is like a hub that's receiving all the signals and sending it over the on the network. Um, the adapters or the routers, they're gonna send out your signals, your Zigbee waves, and then you have your end device like light bulbs or something, or motion sensors or something to give you your actual automation. Now, where do we see this? Typically, we're going to see this in home automation, smart homes. I think nowadays a lot of people have smart light bulbs in their homes. Something like motion sensors, some gas detectors. If you have temperature sensors, humidity sensors, that's all things that can be Zigbee. All these mainly automation, but you can see them in warehousing, for agriculture. If you're gonna do like humidity sensors for your farm, or in manufacturing. There is some use cases. Now there you go. So here we have the warehouse. Um, Now, just as Troy mentioned, we have different technologies here. And in this case, we're going to use Zigbee. Again, we have the Zigbee beacon there, which we can place in our. I'm going to focus here on the offices because we need a smart lighting system for our offices. So I'm going to put a light beacon, a Zigbee beacon inside our office. And this way, I can see here in my 2.4 gigahertz, I can see my signal strength for this area. Now, again, it's all about requirements. So in our areas, now we can define, we have some requirements there where we can say one device, we want to see at least one Zigbee beacon within -60. So in this way, we can start designing for Zigbee beacons to be placed in your building to make sure you have enough coverage for all your smart automation stuff, smart building automation, so you can have enough. Um, so you have enough coverage there. So this way, using Zigbee, uh, and maybe if I change my visualization to number of devices, so now I can see where I have my signal. Maybe I need to add a few more so I can see um, my areas where I want to where I can apply this Zigbee automation. Again, these are now pretty high on the ceiling, so maybe on a lower them to get them closer to your devices. So by lowering them, we can let's do this for all of them. So maybe change them to like 3 meters. So you see, it's gonna be a big change to put them closer to your clients, and this is gonna work out for you. So placing beacons and placing the Zigbee, we can do this right now using AI Pro Online. What do you want to remember there? Maybe if you have a gateway, if you have a smart hub, like for light bulbs, maybe you want to add a second one, because if your gateway is broken or is malfunctioning, you do want to be able to steer your lights for your building automation. So maybe redundancy, plan for redundancy. Also, you don't want to put your beacons too far away from each other. So you see, if I put them too high, I'm not going to have enough signal. So place them right, and don't put them more than like 50 meters away from each other. The Zigbee is going to find its way. It's having 16 channels in 2.4 gigahertz, so it'll find a way, and it'll be resilient, just for use in 2.4. But
On the subject of technologies that operate in 2.4 gigahertz, maybe we can touch on BLE or Bluetooth Low Energy? Because I think probably everybody and their children or mothers or fathers have got some sort of BLE devices. If you've got a watch, you've got headphones, you've got mouse, trackpad, keyboard, they all operate in use Blue BLE, and it operates in the 2.4 gigahertz frequency band. And what actually Bluetooth does, it actually hops around the 2.4 gigahertz frequency band. And it does its best to try and avoid Wi-Fi communication. So even if there is other things going on, Bluetooth will typically hop around it and then avoid the kind of conversations going on there, so you can have communication between your devices. But what we will probably look to kind of like leverage BLE for and planning in Ekahau AI Pro Online for some of the use cases is most likely going to be for asset tracking, wayfinding, potential marketing. If you go to a retail store and you've downloaded the store's app and then you're walking to a location, you walk past a certain store, maybe you would get push notification that, hey, Troy Hans, come into my coffee shop today and you're going to get 20% off my oat milk frappuccino with extra caramel latte and some sprinkles on top with some vegan whipped cream, which I know is your favorite coffee order. So things like that. Also, you probably maybe have gone to some of these fancy stores where you can walk in without even picking up a basket, picking stuff off the shelf, put it in your basket, and then walk out without having to actually pay. Well, you do kind of pay, but it's all done by recognition from as you walk in, as you take the device off the shelf, put it in your basket, it's all recognized and it gets automatically deducted from your account. So lots of really cool things that you can do with that. And Bluetooth, you can see now if I do a quick demo. So this is like our AR Pro 9. I placed an access point here, and you can see we can see multiple different types of radios. So we've got our Wi-Fi radios, we can see we've got a Bluetooth radio, and we've got the ultra-wideband radio. So what I can do now is if I can put an access point, a Wi-Fi access point that's got a radio that's supported with Bluetooth, and let's say I wanted to plan for perhaps having good asset management or wayfinding via BLE. What I can do now is I can change this visualization to go to Bluetooth. Then maybe I want to add in a couple of extra access points. Maybe I want to put one like somewhere, something like this, but I don't want to just see the signal strength. I want to look at the number of devices that can be heard. Perhaps I want to actually maybe not just keep placing Wi-Fi access points. One of the options that we can do, if I go back to the device tool, is we don't have to just place the full access point with all of the different radios. We could actually potentially just place, if I go to Bluetooth, I can pick, I don't know, like say a Mist, for example, and I can start supplementing into my plan additional devices to supplement that kind of like Bluetooth coverage that I'm looking to hopefully achieve to be able to hear the number of devices that can be heard, so I can get a good level of accuracy of asset management and tracking as people are going through the building. So you don't have to place the full blown access point that has all of the different radios. You can supplement them with other beacons as well. So that was a quick demo for our BLE. So yeah, I did touch on it a little bit, right, Hans, about like location services could be one of the big reasons why you want to leverage BLE.
Yeah. So, but if you want to get more accuracy, yeah, BLE can be a good solution. Um, but when you want to do asset tracking, if you want to do asset tracking or some proximity, so if it's close to something, um, depending what's the use case for your location asset tracking, what's the use case? What do you want to track? How close do you want to be? Because sometimes some technologies are like 3, 4, 5 meter. Wi-Fi was like 50 meters before, but the accuracy is key here. How close do you want to get? And this is where the different technologies come into play, and that's where again coming back to requirements, design and check what you want to do. Wideband, it's sub 1 meter, so you can actually if you do it right, you can have a few centimeters accuracy. BLE 3 to 5, depending what you want to do. Now the APs, again, don't put them too high, because if you're like a 10-meter high warehouse, you don't want to put the APs there. So like maximum height like 2.5 to 4 meters. Huh? So and don't put them too wide, because you want to build an area and like a zone, a perimeter. So you know in this area I want to have my accuracy. I want to have my asset tracking. So at least three. We need to have three anchors at least so we can triangulate there, but maybe 4 to have more accuracy. The more the better in this case. Now, where are you going to place them? Well, again, don't put them too far and put them in line of sight because they need to triangulate to each other. So they need to know and they need to see where you are, where you're going. So line of sight, this is very important there. So you have a good accuracy. And place them around your building, place them around your office or area where you want to have the tracking. So anywhere you go, you have your accuracy. Now, ultra-wideband, it's playing in a large spectrum from 3.1 to 10 gigahertz, but we need to have this high precision. If you want to be real accurate, ultra-wideband is where you want to go. It doesn't have very high range, but it can be extremely accurate and has low power. Now it's using 500 megahertz 500 megahertz channel width. So, but by doing a good placement, we can have the accuracy we want. Now, like where do we need this? Huh? If you want to do it in healthcare, if you want to track people, if you want to track a pump or something or beds or something, in healthcare it's or manufacturing. If you want to track AGVs or something like that. There's asset tracking people also for accidents like in constructions or in warehousing again. If someone's coming with the forklift, they get a beeping sound or they will warn you, hey, something, maybe you can avoid a collision there. So like geofencing. Like Matt showed you already with BLE, we can do the same thing. We can do the same thing with ultra wideband. So if I show you here again a quick demo for ultra wideband, I did already Zigbee, but now I can place more EPs in there. So if I'm going back to my Wi-Fi and I take for instance, a Cisco AP, and I'm going to take my 9178. I have my radios. So as Matt mentioned, you have now additional radios. So radio 5 is our ultra wideband radio. I'm using this on channel 9. I can change my TX power. So if you say, well, I'm going to design for this one, I'm going to design for minus 3 dB because ultra wideband is low power. So now I can place one AP there. So I have my Wi-Fi, but now I have also my ultra wideband location. So now I have one AP there, but again, height, it's set to 4.9 meter. We did say don't go beyond 4 meters, so I'm going to lower this a bit. So my EP is not too high. And now I can place more. So because I want to have my accuracy. So there we go. And now in this area, I can hear my clients. So by setting my APs, I can provide my accuracy in my offices. So anywhere I go now, I can find my people. So because as a requirement area, like default requirements for ultra wideband, we have now the Cisco smart spaces, asset tracking, and wayfinding. So if you want to do wayfinding, asset tracking, we can define these requirements. They are basically default built into your AI Pro line.
Thank you, Hans. And Hans, we probably didn't mention it earlier very clearly. Actually, you are one of our amazing Ekahau ECSE instructors. I think one of probably about 15 instructors that we have that teach our ECSE classes globally. And on the subject of training and education, I see a lot of people ask some questions, and especially in the Q&A and as well around how you can like level up your knowledge when it comes to Wi-Fi and using the Ekahau tools. Well, we have a pool of like 15 of the best instructors that can cover all parts of the world and in many different languages. So, depending on where you are and what time zone you're in, you can find an instructor that'll be able to teach a class in your region and in your language. Also, we have 3 different 4-day instructor-led classes that can be delivered either virtually or in person. So the ECSE design, advanced and troubleshooting, and they're very tailored specific for what you would like to achieve from learning. So if it's really about like getting a good understanding about Wi-Fi, designing Wi-Fi networks, how to use the Ekahau tools, getting that good fundamental baseline knowledge, then the design class is a great class for you. Once you've achieved the design class, you can then go on and take our advanced class that has been just recently updated, and I'll go into the agenda of that in the next slide, but we really wanted to focus on key aspects like advanced designs using the complex 3D modeling that we can do now in AI Pro Online, advanced troubleshooting, advanced surveying techniques, and also like keeping a bit to a few more complex things around like floor plan manipulation. And the troubleshooting class, that's what it says on the tin. So if you ever have to troubleshoot a Wi-Fi network, this class is fantastic for you because it teaches you around things to watch out for, the most common issues that you would most likely find in Wi-Fi networks, how to identify them, but not only how to identify them, but also how to fix them and remediate them as fast as possible. We also offer some self-paced video on demand training videos as well that you can watch at your own leisure, and we have many different classes there as well. But just wanted to touch on the advanced class, especially since Hans showed that earlier on today. So the advanced class has been just updated very, very recently. So I think we've maybe had two or three classes now that have run with the new materials, which is getting like fantastic feedback. So if you do need to maybe do a bit more complex, advanced design, surveying, and troubleshooting, then I'd highly recommend that you check out the new updated ECSE advanced class. But Troy, you said earlier that we have another webinar coming up quite soon that might be of interest to some of our guests today.
Yeah, absolutely. And even in light of some recent events, we have a webinar coming up on December 3rd where we'll be discussing some lessons learned from some of the biggest outages of 2025, right? So if you want to get into hear some of those insights, what you can do maybe to fix your own networks, your own deployments, so that you don't get called out on the 2026 iteration of this webinar, maybe something that you want to tune into. So scan that QR code, get registered. If you can attend in person live, that's great. Otherwise, you'll get an email with a copy of the recording following the next webinar there.
Thank you, Troy. And I can see Stu's pop back on screen now. And Dale, I'm sure, is going to come back too, because I know you've been keeping a close eye on the Q&A over the course of the webinar and seen that you've marked a few of the questions that you want to get us to answer live. So, Stu, why don't you kick us off with the first question you wanted to answer on the Q&A?
Yeah, it looks like I might have clicked one by mistake here. But oh, that's is it possible to replace the AI Pro image in AI Pro online like we do in desktop? Are we there yet, Matt?
Are we there yet? So that's a feature that is going to be available shortly. So if you do need to swap out your floor plan in Ekahau AI Pro Online, like you can do in the desktop application, that is something that will be coming very soon. So just keep an eye out for that. But yeah, if you can still currently do it in the desktop application, but in the online one, that's going to be something coming very, very soon.
Great.
Dale, what was one of the questions you wanted to get us to answer
Yeah,
live?
yeah, this question comes from Tyler. So he asked, some of the default values we have for attenuation objects or even wall types for that matter, are these based off worst case scenarios or more so common average attenuation values? But also, can you talk about the ability to create your own custom values within application?
Yeah, I'll let Troy answer that one.
Yeah, and so it kind of relates back to defaults. They're reasonable values. I wouldn't describe them as a worst case of any material type, but they'd be common attenuation values that you'd see for various objects or wall types. And then you can absolutely add your own custom attenuation objects, define the height, the lower edge, the upper edge of those materials. You can leverage the Sidekick 2 to go on site, measure that wall or that attenuation object, measure the value on what you hear for RSSI on one side of the object, measure the value on the other. That delta will give you insight and what you can use to create that customized attenuation object and develop that. Or if you're no longer able to go on site, but you have data from an old Sidekick 2 based project, you can analyze that by just hovering the inspect tool over spots on the floor, seeing what the signal is on one side of the object, and then looking at the inspect tool on the other side of that object, getting a sense of what the attenuation value is, and then leveraging that value to create your own customized objects. So again, just to summarize, they're reasonable starting points for a lot of common objects. But drywall varies so much, right? Is it a 10 mil, 15 mil? Is it a double layer drywall? triple layer? Is it insulated? There's so many complexities to this. These are just values to get you going. But to get the most accurate designs and minimize your risk, if you can go on site and measure real walls for the site you're designing for, that gets you much closer to the truth when you put together your model.
Yeah, great explanation. So, Stu, was there other questions, even if you've already answered them, that you might be thinking that's good to just reiterate to the rest of the audience that
Yeah,
might not have seen the
absolutely. Yeah,
question?
I think one of the things is that we had a question here that was really key is when we're planning how important the Sidekick 2 is to actually gathering some of that information. As you guys were listening out there in there is maybe talking about, how important that Sidekick 2 was for you guys to plan that 4G and that 5G and all those other new technologies we got coming in.
Yeah, so I was going to throw it over to Hans, but I feel that might be a little bit unfair since it's quite Ekahau product related. So the next one we'll give to Hans. But yeah, just to reemphasize what you said there, Stu, I think it's super cool and a really powerful thing that the research team has been able to kind of take that data that we've collected with the Psychic 2 that was measured on either 2.4, 5, or 6 gigahertz with the survey data and looking at the floor plans and all of that information, lots of really complex calculations going on there. So based on the data we've collected, AI, machine learning, but we can now use that data to, even though we've collected it on in Wi-Fi, we can use that data to now predict different wireless technologies, heat maps, and RF propagations, and how they're going to interact with your unique specific environment without having to draw a single wall or a single obstacle. And yeah, I think it's a really great way to be able to plan for upgrading your Wi-Fi networks, but also planning if you want to use other wireless technologies that we've mentioned today. So yeah, I think it's a great new addition that we will be able to plan for. And I thought it was super cool when we first heard that we could do that.
Yeah, and I think that's great because it follows up to another question is, um, can I just use my, nick on my notebook to do a survey? But really, that's where you're explaining right there is that how we're able to take that intrinsic empirical data and make some additional sense of it.
And
Yes.
it's that baseline, it's that accuracy you get of using the Sidekick 2. We have that common reference point that feeds into all those models. If you just a built-in Wi-Fi NIC or a USB adapter, or if you get a mix of different products that you're using to collect your data, you lose that consistency and the stability in that starting point to then input into these calculation models to predict and estimate what other frequency attenuation characteristics would be.
Yeah, perfect. Dale, was there any other questions that you wanted to go over or the answer that you thought maybe we could to capture again?
Yeah, one final question. So you all, you revealed some nice capabilities coming from a multi-tech planning capability. Outside of those technologies that you covered today, if there's others that might be that users might be interested in adding, what are some ways that they can go about conveying that interest to get it added?
Oh, actually, you know what? I'm gonna get Stu to answer that question.
I'm just getting ready to type that into the chat. I do want you. You know what? I love that. Head over to ekahau.uservoice.com and throw in and log in there, and you should actually be able to add that feature request or look at other feature requests in there, upvote those, and get that in there. And the more you guys upvote in there, we get that into consideration and we get that off into the product team. So it's really important. So go over there, have a look, and get those questions in. But we did capture a few here in the webinar today, and I do like a few of those, and we'll get some of those going for you.
I have a sneaky suspicion that a Mr. Troy Martin might be putting forward a request for a specific technology that sounds like Laura.
When
Yeah.
nice.
Um, Han, since we have you here, I was hoping we could fire a question over to you that came from the chat on the Q&A, but I have one for you. So, out of the new wireless technologies that you can now plan for in Ekahau AI Pro Online, Hans, is there one particular technology that you're most excited about planning for now?
Yeah, I have been playing in the past with ultra-wideband, and I was struggling back then to see, okay, but where should I place my anchors? Should I place it behind the wall? Where do I get my accuracy from? And I noticed I wasn't doing it right back then, but I had no clue how to calculate, how to calibrate it. And now I can. Now I can see, okay, if I place them in that corner and that around the building, around my office, how is this going to be? How are my receivers going to see the ultra wideband signal? How are my tags are going to respond to that? So that's very cool.
We thanks, Hans. We think so too. And thank you so much for taking the time to present with us again. For me, the second time in 2 days. I know our audience really appreciated having your insights. And if you enjoyed hearing from Hans today, then yeah, get yourself signed up for an upcoming ECSE class, and he may be one of the instructors that you get in an upcoming class. But yeah, so thank you very much, Hans, Troy, Stu, Dale, and the rest of the Ekahau marketing team for putting us all together, and all of you wonderful guys and girls that have joined us on the webinar today. Do sign up for that down detector one. That's going to be really interesting. Excuse me. And then we have just one final Ekahau webinar left of the year in December, and then yeah, that's going to be it for 2025. I can't believe it's gone so quick. So yeah, make sure you get signed up for the last kind of webinars that we're going to be doing this year.
Coming up on December 11th.
Yeah. Thanks, Troy. I thought it was December 11th, but I wasn't quite sure, so I didn't want to say I'll say some random day in December and be wrong because yeah, I wouldn't want to point people in the wrong direction. But yeah, no. Thank you, everybody, and we'll look forward to either seeing you on the Down Detector webinar or on December 11th for our last Ekahau webinar of the year.
Thanks for joining, everyone.